We're going to learn a new way to solve quadratic equations today called completing the square. And we can always solve by completing the square. It's just sometimes a little bit more involved and a little bit more difficult depending on the quadratic equation. So we really do want to continue to solve by square roots if we can, and to solve by factoring if we can. But maybe we see something and we can't figure out how it factors. We're going to be able to complete the square and get the same solution. So the first thing that we have here are the steps for completing the square. And if you need to pause the video to write these down in your notes, you can certainly do that. But the first thing that we're going to do is write the left-hand side of the equation as a 1x squared plus bx equals everything else. And it is really important that you do this first. And again, if a is not equal to 1, we have to divide all parts of the equation by a, even if it results in fractional values. Then you're going to complete the square by adding b over 2 squared to both sides of the equation. Make sure that you're adding to both sides. We have to keep things balanced. Then you're going to factor and write the left-hand side as a binomial squared. So essentially you're going to have something squared equals everything else. It'll be like an x plus or minus a number. Then you can solve by taking square roots. So you'll take the square root of each side, you'll solve for x, and simplify. So before we start the whole process of completing the square, we're just going to figure out what we need in order to write something as a binomial squared. So here we have a 1x squared plus bx. We need to figure out what this number is that's going to cause us to be able to write it as the square of a binomial. So essentially that is the b over 2 squared component that when we solve, we'll be adding to both sides of the equation. So here, b is 14 over 2 squared is a 7 squared, or 49. So that means c is going to be 49. So I can write this as x squared plus 14x plus 49. And then to write it as a binomial squared, essentially what I'm doing is I'm factoring this. So x times x is x squared. 7 times 7 is 49. Both positive, so they multiply to 49 and add to 14, which I then am going to write as a binomial squared since both set of parentheses match. So we're going to do this again. Again, just finding that value for c that allows us to do that. So it's a 1x squared plus bx plus c. So that means we can go ahead and calculate b over 2 squared. So b here is negative 2 over 2 squared, which is a negative 1 squared, which is positive 1. So c is equal to positive 1. Watch your signs. Anytime you're squaring, you're going to get a positive result. So you're always adding a positive number in for c. So that means we've got x squared minus 2x plus 1. We then want to factor that. So x times x for the x squared, 1 times 1 for the 1. Both need to be negative, so they add to negative 2x. And then we can write that as a binomial squared. Okay, so one last example. Here we've got x squared minus 9x plus c. So we want to figure out what the c value is using that b over 2 squared formula. So here b is negative 9 over 2 squared. So now we have something that's not a nice integer value. 9 over 2 doesn't reduce. So we're just going to square the numerator and square the denominator. That's 81 over 4. So x squared minus 9x plus 81 over 4. We want to leave it as the fraction because we're going to factor, and it seems like it's going to be really tricky. Like, what are we going to do so that we can multiply those numbers to 81 over 4 so that they'll add to negative 9? You want something times itself that's going to give you 81 over 4, which is essentially back to whatever b over 2 was. So it's going to be a 9 over 2 and 9 over 2, because when I multiply those together, I've got 9 times 9, which is 81. I've got 2 times 2, which is 4. And then I need them both to be negative so they combine to give me that negative 9 in the middle. So then again, x minus 9 over 2 quantity squared would be my binomial squared. Now we're going to go through that whole process of completing the square. So we just saw how we can do that b over 2, square it, put it in there, and write it as a binomial squared. But now we're going to go through the whole process of, once we do that, how do we solve the equation? So here, if you remember, the first step I said was always to write it as a 1x squared plus bx equals everything else. So I'm going to move this 13 over. I'm going to make this x squared minus 10x equals negative 13. Once I've done that, now I can calculate b over 2 and square it. That gets added to both sides. So in this particular case, b is negative 10 over 2 squared. That gives me negative 5 squared, which is equal to 25. Let me get rid of that. Okay, equals 25. So 25 is going to go here and here. So this becomes x squared minus 10x plus 25 equals negative 13 plus 25. And you don't have to show this over here, but I do like to write it separately so that when you're looking back at the work, you can see that, yes, I did remember to add it to both sides. Now we're going to factor on the left. So x times x for the x squared, 5 times 5 for the 25, both minus, so they add to negative 10. And now on the right, I can combine these. That's going to give me a 12. And now I have to write this as a binomial squared. So I'm going to come up here. This is going to be x minus 5 to the second power equals 12. And now I'm going to solve by taking the square root. So I take square roots of both sides. X minus 5 equals plus or minus the square root of 12. And then I need to solve for x and I need to simplify. And you can do that in either order. But I am going to need to add 5. 5 cannot be combined with that square root of 12. So it's just x equals 5 plus or minus the square root of 12. And then 12 is 4 times 3. And 4 is 2 times 2. So I can pull that pair of 2's out, and they're going to go right in front of the radical. So it's going to be 5 plus or minus 2 square roots of 3. Here's another example. So again, we have to start by writing it as a 1x squared plus bx equals everything else. So I need to move this 27 over. So this is 3x squared minus 12x equals negative 27. I also need it to be a 1x squared. So I have to divide everything by 3. So that's going to be an x squared minus 4x equals negative 9. Now that I'm in this form, I can do b over 2 squared and add it to both sides, but not until I'm in this form. If I do it before I have a 1x squared, it's not going to work to complete the square. So just really be careful there. Okay, so b over 2 squared here is negative 4 over 2 squared. So it's a negative 2 squared, or 4. And again, that 4 gets added to both sides of the equation. So it's going to look like an x squared minus 4x plus 4 equals negative 9 plus 4. And again, if you jump straight to saying that's a negative 5 on the right, that's okay. On the left, I have to factor. So x times x for the x squared, 2 times 2 for the 4, both negative, so they multiply to positive 4 and add to negative 4. So I'm going to rewrite that as a binomial squared. So x minus 2 quantity squared equals negative 5. And then I take the square root of both sides. So on the left, I have x minus 2. On the right, I have plus or minus. Remember, negative square roots we have to write as I times the square root of a positive. And then lastly, we need to add that 2. 2 can't be combined with that I square roots of 5, so it just stays as 2 plus or minus I square roots of 5. You can also use completing the square to rewrite quadratics in vertex form. And essentially, you're just going to complete steps 1 through 3 of completing the square. So you're going to write it as a 1x squared plus bx equals everything else. Then do your b over 2 squared to both sides, and then you're going to factor. Once you've done that, there's nothing to solve for. We're just going to write it in vertex form. So you may have to move some things back around, but you're pretty much done at that point. So here's an example, x squared plus 14x plus 44. I'm going to write it in vertex form and identify the vertex. So first thing is to make it a 1x squared plus bx. So this 44 is going to have to go onto the other side. So I'm just going to write it as y minus 44 because I do want to keep that y, because when I write it in vertex form, it's the y equals a times the parentheses squared plus k. So y minus 44 equals x squared plus 14x. Now I can calculate b over 2 squared. That's a 14 over 2 squared. So 7 squared or 49. That gets added to both sides of my equation. So I have y minus 44 plus 49 equals x squared plus 14x plus 49. On the left, I can combine these two constant terms. So a negative 44 and a positive 49, that's going to be a y plus 5. On the right, I want to factor. So x times x for the x squared, 7 times 7 for the 49, both positive, so they add to that 14x. And then I want to write this as a binomial squared. So I'm going to say, okay, y plus 5 equals x plus 7 quantity squared. I'm almost in vertex form. Remember, vertex form looks like this. So I need to move that 5 back over. I'm subtracting it. I'm not going to try and shove it into those parentheses. That's what the k is. It gets tacked on the end. So y equals x plus 7 quantity squared minus 5. And then remember, to identify the vertex, your vertex is just located at hk. So my vertex here, the number with the x gives me the x coordinate, but again, it's always the opposite of the sign that's in there. So it's going to be at negative 7. The number that's on the outside is my y coordinate. So negative 7, negative 5. Here's another one with vertex form. So again, just like the last one, we've got to move that 53 over. So y minus 53 equals x squared plus 16x. Now we can go ahead and calculate b over 2 squared. So it's 16 over 2 squared, or 8 squared. So 64 is going to get added to both sides. So we've got y minus 53 plus 64 equals x squared plus 16x plus 64. I can then add these together, so negative 53 and 64, that'll give me y plus 11. I'm going to factor on the right, so that'll be an x plus 8 and an x plus 8. And then I'm going to rewrite that as x plus 8 quantity squared. Then I have to move that 11 over, and that becomes the k, so x plus 8 quantity squared minus 11. That's my vertex form. And I'll go over here to write my vertex. Vertex is located at h, which is the opposite of that 8, and then k, which is that negative 11. So for your homework assignment, you have some problems in your book, 3 to 19 odds, and then 25 to 35 odds. Here you're completing the square, so it's that whole process of going through all of the steps. In the 3 to 19, some of these you're just factoring, and then some you're just figuring out that value of c that makes it factorable, like some of those initial examples we saw.